These are notes for adding and subtracting polynomials in Unit 1. Our essential question is, what is a polynomial and how is it classified? All right, so polynomial is a new word for us. So we're going to go through some vocabulary and then kind of build up to what a polynomial is. So, a term. So this is something we talk about a lot, but it's kind of hard to give a definition to it. So terms are separated by plus and minus signs. Oops, I need to silence my phone. Sorry about that. All right, so they're separated by plus and minus signs. So here's an example, just on the side. You don't have to write this actually. So 5x minus 3, that's two terms, right? Because 5x is a term and 3 is a term, and they're separated by a plus or minus sign. So in that case, we have two terms. So two terms, a term is just like a kind of a grouping or an item kind of thing. All right, and then the next three words here, you would notice that maybe the prefix is kind of familiar to you. So we have mono, bi, and tri. So mono means one, bi means two, and tri means three. So if I have a monomial, that is going to be one term. Okay, so here's some examples of what a monomial might be. 5x, or maybe 3x squared, or 7xy. So these are all one term, right? They're just one grouping, all by themselves. Binomial, that's going to be two terms. So example with that of that would be 5x minus 3, kind of the one that we had at the beginning, or 7 minus 3x squared. That's also one. Actually, let's do a plus on that one so we know. So they're two terms. They're two different terms separated by plus or minus. All right, trinomial would be three terms. Example of that, 5 minus 2x squared plus 9x. So that's three terms. Do we see how there's three? 1, 2, 3. So that's a trinomial. Now, a polynomial, you're probably thinking, oh, it's probably four or more. But a polynomial is kind of an umbrella term. It kind of covers everything. So every monomial is a polynomial. Every trinomial is a polynomial. Every binomial is a polynomial. So a polynomial is one or more terms. So I'm not going to really give an example of that just because all the previous ones were examples. And then you could have something that's 7 terms long, and that's also a polynomial. So 1 to 7, 1 to 1 billion, right? So as many terms as it is a polynomial. All right, the degree of a polynomial I'm going to define here. So bear with me with my definition. So the highest exponent in the polynomial. So the highest exponent in the polynomial. So let's get an example so we kind of know what we're going after here, what we're talking about. So I have 5x squared minus 3 plus 8x to the 7th plus 1003x. So if you could go ahead and copy that down, that would be awesome. So I just wrote down a lot. So if you want to write that down, that would be great. All right, so the degree of this polynomial would be the one with the highest exponent. So whichever the highest exponent is, and the highest exponent in this case is 7. So this would be a 7th degree polynomial. Okay, so it's whatever the highest exponent is. That's going to be your degree. Okay. Standard form of a polynomial. So I'm going to kind of word this in a weird way, but the definition's pretty simple, so I'm going to kind of word this weird. So the order of exponents, well, let me reword that. the order of your terms, or the terms, with the greatest exponent to least exponent, or the smallest exponent. The greatest exponent to the smallest exponent. Because least doesn't really make sense there. All right, let's talk about what an example for that would be. So I'm going to use the example that I used up there. So you want to start with the greatest exponent first. So you're always going to look for the term with the greatest exponent. And we already declared that the 7 was the highest exponent. So that's the term that's going to come first. So it's going to be 8x to the 7th. Okay, well, what's the next term? Well, the next term is going to be 5x squared because that's the next highest exponent. And that's a positive 5x squared. So there's a plus sign in front of that. Okay, then I have plus 1003x. And you're like, why is that number so big? Well, it's just big, right? We don't know. But it doesn't matter that that number in the front is bigger. Our coefficient, it doesn't matter that it's huge. The only thing we're caring about for standard form is we're ordering it from greatest to smallest, and that's based on just the exponent alone. And then we have our minus 3, so that's just at the end. So make sure you bring that negative sign with it. So that's going to be the standard form. Okay. So now we're going to do some examples kind of working with those. For the following expressions, determine the degree and classify the polynomial. Then put it in standard form. Well, number 1, I have 1 plus x to the 5th plus 3x to the 3rd. So to do the degree, it's going to be whatever the highest exponent is. And the highest exponent here is 5. So this is a 5th degree polynomial. And then I have to classify it. And the classification of this, since there are 3 terms, would be a trinomial. And then lastly, I have to put it into standard form. You always start with the highest exponent first. That's going to be x to the 5th. And then you're going to have plus 3x cubed, and then plus 7. Because that 7 is positive, so it is going to be plus 7. All right, and if you feel comfortable with this, go ahead and move on to the next 2. And I'm going to do that very shortly. All right, so our degree here is going to be, the highest is 2, because the other one is technically what? It's technically 1. So 2 is bigger than 1. So our degree here would be a 2nd degree. The classification here would be a binomial because there are 2 terms. And then standard form of this, well, the highest degree is the 2, so we start off with negative 5x squared plus 8x. So you do want to take the sign that's in front of it with it. So make sure you do that. All right, next. For number 3, our highest exponent here is a 7. So this is a 7th degree polynomial. And how I would classify it is by how many terms it has. So it has definitely more than 3. So we're just going to call it a general polynomial because it doesn't have a special name for it. Only polynomials that have 1, 2, or 3 terms have special names. And then lastly, we're going to order this. So we're going to start off with 3x to the 7th because that's the highest exponent. Move on to 4x to the 5th. Minus 8x cubed plus 7x minus 2. So 7x does come before the negative 2, and the reason why is because the exponent on the x is a 1, whereas there is no variable here, so your exponent is technically 0, or the degree of that term is technically 0. Okay, now we're going to go ahead and move into adding and subtracting. So we have 4x squared plus 3 plus 3x plus 7x squared minus 1. So normally when we have parentheses, we want to distribute. But the thing that is in front of our parentheses here are just 1s. And when we distribute positive 1s to both things, it doesn't change anything. So I'm just going to drop my parentheses. And then from here, I'm going to combine like terms. Well, I need to simplify and I need to combine. Well, so what does it mean to be a like term? Well, like terms are terms that have the exact same variables and the same exponents. So for example, 4x squared and positive 7x squared are like terms. They're like terms because they have the same variable and exponent. So this is going to be 11x squared. Okay? Next I notice, oh, I have positive 3 and I have negative 1, and those are like terms. I can add and subtract those. So 3 minus 1 is going to give me positive 2. And then I have plus 3x, no like terms with that, so it's going to be tacked on at the end here. None of these are like terms, so it is simplified. However, it is not in standard form. So I am going to move it to standard form. And standard form is going to be the highest to lowest exponent. So in order for it to be in standard form, this needs to be in the middle here. So I have 11x squared plus 3x plus 2. And that is my standard form, and it is simplified. So hopefully that wasn't too bad. Number 2, we have 3x squared plus 4x minus 5 plus 8 minus x minus 3x squared. So hopefully you are taking notes and you have them pre-printed, or you're going to have a lot of writing to do. So make sure you are taking notes, because if you're not taking notes, you're wrong. So be taking notes. Again, we have parentheses here, but we have a positive 1 on both sets of parentheses, so we can just drop the parentheses since 1 times that doesn't really matter, or it doesn't change anything. So 3x squared plus 4x minus 5 plus 8 minus x minus 3x squared. Okay, let's look for some like terms. 3x squared, and then I also have minus 3x squared. So what's happening here? Well, if I have 3x squared and I take away 3x squared, what do I have left? And your answer is probably either 0 or it's probably x squared. So let's talk about that. 3x squared and I take away 3x squared. Well, if I have 3 apples and then I take away 3 apples, how many apples do I have left? 0. Same thing with the x squared. If I have 3x squared and I take away 3x squared, it's 0. I have nothing left. It doesn't make sense to say that there's x squared left because you're saying 3 minus 3 is 1. That doesn't make sense. So it is indeed 0. So because of that, these two guys cancel each other out and they no longer exist. So we can actually move on to our next thing. So let's look. Do we have any other like terms we can combine? Well, I have positive 4x minus x here, and that's going to give me 3x. And then I have negative 5 plus 8, which gives me positive 3. And that those are not like terms, so I know that is completely simplified. All right, moving on to number 3. We have 5x squared minus 3x plus 6 minus 3x squared minus 2x plus 3. What's different about this one? Here we're subtracting our polynomials. So this has a positive 1 in front of it. So if I distribute this positive 1, it stays the same. But this is technically a negative 1. And when I distribute a negative 1, it doesn't keep it the same. What happens is it changes all of my signs. So the first set of parentheses I can drop. But the second set I cannot. So I'm going to have to distribute here. So negative times 3x squared is going to be negative 3x squared. Negative times negative 2x is going to be positive 2x, because negative 1 times negative 2 is positive 2. And then negative 1 times 3 is going to be negative 3. So it changed all of my signs. None of my terms changed, just the signs. So now I'm going to look for some like terms. I have 5x squared minus 3x squared. That's going to be 2x squared. And then I have, what else do I have here? I have negative 3x plus 2x, and that's going to be negative x, or negative 1x. And then lastly, I have 6 minus 3, and that's going to give me a positive 3. And this is in standard form, and so I am done. All right, moving on to number 4, 5x plus 6y plus 3x minus 4z. Now, what's different is that we have 3 variables here, but we treat it the same. Again, positive 1 in the front, positive 1 in the front. When I distribute, nothing happens, so they can drop. Then I'm going to look for some like terms. 5x can combine with positive 3x, which gives me 8x. My 6y can't combine with anything, and neither can my 4z. So those are just going to stay there. They don't really do anything, but they are still there. They just don't have any like terms that can be combined. So that's what it is. All we could combine were those x's. All right, number 5. 4x minus 3y minus 5x plus 8y. Well, This one here, when I distribute, doesn't change anything, but this negative one over here will. So I do need to distribute that negative over there. So I can drop the parentheses in the front, but I can't drop them for the back polynomial. So negative 1 times 5x is negative 5x. Negative 1 times 8y is going to be negative 8y. So that's going to be a mistake that we forget to make the mistake that we make all the time is forgetting to distribute the negative to every single term in those parentheses. So, for example, number 3, when I distributed over here, there were 3 terms in the parentheses, so I distributed to all 3. Here I have 2, so I distributed to all 2. Now we're going to look for our like terms. My like terms, let's see, I have 4x minus 5x, so that's going to be negative 1x, or just negative x. And then I also have y's that are like terms, so negative 3y minus 8y, and that's going to be negative 11y. So hopefully feel comfortable with this. So again, we're just kind of doing the same thing over and over. We're just distributing and then combining like terms. All right, 6 is a little different because we actually have a number in front of our parentheses other than 1 and negative 1. So regardless, I still have to distribute. How many terms are in here? 3. That means I must be distributing 3 times. So 3 times 2x cubed is 6x cubed. 3 times negative x squared is negative 3x squared. 3 times 5 is 15. And I am going fast for these notes, and it's mostly because I know this is a recording. So you can always pause the video, you can always slow down the video, and you can always go back. So that's why I'm going a little bit fast. So if you do feel like you're tripped up on something, you can always go back. And then over here, I have a negative 2 I need to distribute. So negative 2 times 4x is going to be negative 8x. Negative 2 times 3x squared is negative 6x squared. Negative 2 times negative 1 is positive 2. All right, looking for like terms now. Well, let's talk. 6x cubed has no like terms with anything else, so 6x cubed is going to stay in the front. Okay, well, what about negative 3x squared? Well, that I can combine with negative 6x squared, which to be negative 9x squared. Okay, looks like my negative 8x here doesn't combine with anything, so that's going to stay. And then lastly, it looks like I have one more like term, 15 plus 2, which gives me positive 17. So that's going to be my simplified polynomial there. So let's go back and see if we can classify these. So number 2, this is a first degree binomial. Binomial because it is 2 terms, and the highest degree is technically a 1. On number 3, this is a trinomial, and it is a second degree trinomial because your highest exponent is a 2. On number 4, it is a trinomial. We wouldn't really classify something like this because there's different variables. So I would just say trinomial. Same thing with number 5. Different variables, so it's a binomial for sure, but we don't really know the degree. Number 6, that's going to be a polynomial because it's more than 3 terms, so we don't have a special name for it. And the highest degree is 3, so it's a third degree polynomial. All right, so you have 2 problems left in the notes. Number 7 is 2m times m plus 5 minus 3m times 2 minus m. So we're going to go over a little short lesson real quick. So let's talk. Okay, and this is important, so please pay attention. All right, if I have x times x, actually x plus x, what does that equal? 2x, right? So let's go over here and use real numbers. Let's pretend x is 4. So we have 4 plus 4. What does that equal? 8. How else can we write that? We can also write that as 2 times 4, right? So it's the same thing as this concept, 2 times whatever x was. Okay, well, let's talk about x times x. Well, if x is 4, 4 times 4 is what? 16. How else can you write that? How else can you write 16? You could also write it as 4 squared, right? Because 4 squared means 4 times 4. If 4 times 4 is 4 squared, x times x is x squared. So that's going to be a big mistake we make all the time. 2x and x squared are not the same thing, right? Because 4 plus 4 is 8, 4 times 4 is 16. 8 and 16 are definitely not the same. So when we have x plus x, that is 2x. But if we have x times x, that's x squared. Okay, because remember, squared means you're multiplying something by itself twice. So, now that we've gone through that lesson, if you have a problem with that, please let me know, because that is something that we do struggle with in Algebra 1. So, here we have sets of parentheses, and I'm going to distribute like normal. 2m times m is going to be 2m squared. So, instead of it being just like normal, like we haven't seen any exponents, right? So, m times m is m squared. 2m times 5 is going to be 10m. So you've done some stuff like that before, where you've just multiplied a constant with a term with a variable. That first part is the part that we mess up a little bit. All right, and then this next part, we're going to do negative 3m times 2, that's negative 6m, and then negative 3m times negative m. Well, I know it's going to be positive because a negative times a negative is positive. We have a 3. And then we have m times m again, which is m squared. So remember, m times m squared. M plus m is 2m. So that's where you want to make sure you get this part up here, because this part is the tricky part. Now, you're going to go home. You're going to go on and combine like terms if you have any. Well, I have 2m squared, and I have a positive 3m squared, so I can add those, and that's going to give me 5m squared. And then I have 10m minus 6m, and that's going to be plus 4m. And that is that one. All right, number 8 is our only word problem. A rectangle has a length of 4x squared minus 2x plus 7 and a width of 3x minus 1. Find an expression to represent the perimeter of the rectangle. All right, so we want to represent the perimeter of the rectangle, and it's asking us to find an expression, which means this is not an equation. We are just asked to simplify and create an expression. Well, what is the perimeter of a rectangle? How do you find the perimeter of a rectangle? Well, you would add up all the sides, right? So let's draw a rectangle real quick. All right, so I have a rectangle. Now, I don't know, let's pretend like we don't know, but let's say we don't know the formula of perimeter. Let's find out what it is. Well, I have the length, the width, and the width. And I know for perimeter I need to add up all the sides. So that would mean W plus L plus W plus L, right? I have two widths, and I'm adding my length. So width plus length plus width plus length. I add up all the sides. Well, do I see any like terms? Yeah, I do. All right, so I have perimeter equals 2w, and then I have 2 L's, so that's going to be plus 2L. So this is the formula for, I'm having trouble speaking. This is a formula for perimeter of a rectangle. So if you forget it, you can always learn it. Like you can always create it yourself, because you can draw a rectangle and then figure it out. So that's what we did. I pretended like I didn't know, and I just kind of used my knowledge from there. All right, there are two ways to solve this problem. I'm going to show you the short way, and then we're going to talk about the long way, because sometimes you forget the short way, and then you have to do it the long way. Okay, well, what do we know? We know the length is 4x squared minus 2x plus 7. So 4x squared minus 2x plus 7 is my length, which also means that it's the length down here, because remember, rectangles have the same lengths and same widths as the other side. And then this says the width is 3x minus 1, right? Those are our length and width. Well, the short way is to use this formula. So let's use the formula. We have perimeter equals 2L plus 2W, or 2W plus 2L. Honestly, it doesn't really matter. I'm going to keep it like that. So what is L? L is my length, and my length is this green stuff over here. So that's what I'm going to do. So I have 2 times 4x squared minus 2x plus 7. So I've just substituted whatever my length was. Now I'm going to add 2 times my width, which is 3x minus 1. So whatever my width was. So all I did there was substitute my values. So if your width was 3, you would put in a 3. If your length was 5, you would put in a 5, right? But in this case, we have algebra, and we have a binomial and a trinomial. And here there are parentheses because you're multiplying it by the entire polynomial, not just the first part. So I'm going to distribute here, so I know P equals this. I'll make that dark blue actually. P equals this. And I'm going to move this down because I don't have enough room. So, oops, and I dropped the 2. The 2 is now gone. I don't know where it went. 2. All right, so we're going to distribute the 2. So 2 times 4x squared is 8x squared. 2 times negative 2x is negative 4x. And then 2 times 7 is 14. So I took 2 and I multiplied it by my length because that's the formula. And because there's 2 lengths. All right, and then we have 2 times 3x, which is 6x. 2 times negative 1, which is negative 2. From here, I'm going to combine my like terms. So, like terms, I have 8x squared. And that's all. I only have 8x squared, so I can't really do anything with that. So I'm going to leave it as 8x squared. Okay, I have 4x, negative 4x, plus 6x, which gives me negative 2x. And then I have 14 minus 2, which is going to be a positive 12. So it looks like this is the expression for my perimeter. 8x squared minus 2x plus 12. That's the short way. Here's the long way. The long way is doing it by just adding up each side individually. So I had 3x minus 1 plus 4x squared minus 2x plus 7 plus 3x minus 1, come on, plus 4x squared minus 2x plus 7. So this is just adding up every single side. So if you can see, these are my lengths, these are my widths from earlier. Do we see that? This is using this first formula in case you forget. So if you forget your formula, obviously you can do this. So we're going to do this and see if we get the same thing. So let's see if we have any like terms. I have 3x that I could combine with negative 2x, 3x, and negative 2x. So 3x minus 2x is going to be 1x, plus 3x is 4x, and then minus 2x is positive 2x. Oh, I see the mistake I made up here. Whoops. So, sorry, negative 4x plus 6x is positive 2x. So that's my bad. I messed up there. I added incorrectly, which is why I got 2x down here as well. So that should be 2x. So 3x plus minus 2x is 1x, plus 3x is 4x, minus 2x is positive 2x. So that is good. Now we're going to look at our constants, which is negative 1, plus 7, minus 1, and positive 7. So, whoops, all of our constants here. Well, negative 1 plus 7 is 6. Minus 1 is, negative 1 plus 7 is 6. Minus 1 is, oh my gosh, I am having a brain fart. Okay, negative 1 plus 7 is 6. 6 minus 1 is 5. 5 plus 7 is 12. I am so sorry. Okay, and then last but not least, I see that I have positive 4x squared plus 4x squared. So these are both like terms, and that gives me 8x squared. So do we see how these are, this is exactly the same as this previous answer here? So again, it doesn't really matter how you do it because you get the same answer. One way is just a little less writing than the other, you know? All right, if you have any questions, please feel free to ask me, but other than that, the notes are open.